Mars is the fourth planet from the Sun and the second smallest in the solar system. It has a thin atmosphere, a cold and dry climate, and a surface that is mostly covered by dust and rocks. However, some scientists and visionaries have imagined a different future for Mars, one where it is transformed into a habitable planet with a thick atmosphere, liquid water, and even plants and animals. The process of altering the environment of a planet to make it more Earth-like is known as terraforming. This means modifying the environment of a planet to make it more suitable for living organisms. Terraforming Mars would involve changing its atmosphere, temperature, water cycle, and biosphere to make them more Earth-like. This would require a massive amount of resources, technology, and time, but it could also bring many benefits for humanity and science. One of the main reasons why some people are interested in terraforming Mars is to enable the long-term colonization of the planet. Mars is the most Earth-like planet in the solar system, with a similar day and night cycle, seasons, and axial tilt. It also has abundant resources, such as water ice, carbon dioxide, and minerals, that could be used to support human settlements. Terraforming Mars would make it easier for humans to live on the surface without relying on artificial habitats or protective suits. Another reason for terraforming Mars is to expand the diversity and resilience of life in the universe. By introducing terrestrial life forms to Mars, we could create a new biosphere that would evolve and adapt to the Martian environment. Terraforming Mars could also serve as a backup plan for Earth in case of global catastrophe that threatens the survival of our species or our planet. However, terraforming Mars is not a simple or straightforward task. It would require overcoming several major challenges and limitations. One of these is countering the effects of space weather. Mars does not have a global magnetic field like Earth, which means it is exposed to harmful radiation and solar wind that strip away its atmosphere over time. To prevent this, we would need to create an artificial magnetosphere around Mars or shield it from space weather. Another method is increasing the atmospheric pressure and temperature. The current atmospheric pressure on Mars is less than 1% of Earth's, which means that liquid water cannot exist on the surface. To raise the pressure and temperature, we would need to release large amounts of greenhouse gases into the atmosphere, such as carbon dioxide and water vapor. These gases could be obtained from the Martian polar caps, minerals, and soil, or imported from other sources. One other method is creating a stable climate and water cycle. Even if we manage to increase the atmospheric pressure and temperature on Mars, we would still need to ensure that they remain stable and suitable for life. This would require creating a balance between the incoming solar radiation and the outgoing infrared radiation, as well as regulating the distribution and circulation of heat and moisture around the planet. We also can't talk about terraforming without addressing the effects on humans themselves, since we are the ones who will be on there. Living on Mars would not be easy or comfortable. There are many hardships and challenges that people would face on the red planet. The distance and isolation. Mars is about 225 million kilometers away from Earth at its closest point, and about 400 million kilometers away at its furthest. This means that communication with Earth would take between 4 and 24 minutes one way, depending on the position of the planets. This would make it difficult to maintain regular contact with family and friends, as well as to receive timely support and guidance from mission control. Moreover, Mars has no natural satellites or other planets nearby, so the Martian colonists would feel really isolated and lonely in the vast emptiness of space. We also can't talk about the hardships on human life without addressing the harsh environment. Mars has a very thin atmosphere that provides little protection from solar radiation and meteoroids. The average surface temperature is about -63 degrees Celsius, but it can vary from -143 degrees at the poles to 35 degrees Celsius at the equator. The surface is also covered with dust and rocks that can damage equipment and vehicles. The gravity on Mars is only 38% of that on Earth, which means that people would have to adjust to a lower weight and a different sense of balance. The low gravity could also cause health problems such as muscle atrophy, bone loss, and cardiovascular issues. Another issue we'd have to face is the psychological stress. Living on Mars would be very stressful for the human mind and body. The colonists would have to cope with a constant threat of danger, such as equipment failure, accidents, illness, or attack by hostile forces. Hostile forces? What? They would also have to deal with boredom, monotony, and lack of privacy in a confined space with limited resources and activities. They would have to work hard to maintain their physical and mental health, as well as their social, emotional well-being. They would have to develop a strong sense of teamwork, cooperation, and resilience to survive and thrive on Mars. These are some of the hardships that people would have to face on Mars. However, they are not insurmountable. With proper planning, preparation, and technology, humans could overcome these challenges and make Mars their new home. Living on Mars would also offer many benefits and opportunities such as scientific discovery, exploration, innovation, and inspiration. It would be a great adventure and a noble endeavor for humanity. Thank you for watching.